Last night I was in my bedroom catching up.
Everybody pay close attention because I'm seeing a few wrong answers here. So I'm seeing a few answers such as, yes, it's a dilation, not specific enough. Okay, this person said it's a dilation, but also they were checking the ratios, but they were not checking them correctly. This person just said yes, not an acceptable answer. Yes, the sides are similar, okay, but you need to show the math behind it. Okay, good. This person showed the math, except for they did set it up wrong. Same with this person. Same with, nope, this person set it up right. Nico, good job. Okay, a few more wrong ones set up wrong. So everybody, you need to pay close attention because you are forgetting how to do this stuff, okay? So everybody closely, paying attention. This is a bigger triangle, this is a small triangle. We're asked if they're similar. Well, we're not going to be using angles, right? We don't have any angles. We were not given any angles. But if we were given the angles, what do we know about similar triangles? The angles are the, what? The angles are the same. Guys, do you remember that? Okay. Now looking at this, these would be similar if the ratio of corresponding sides are equal, right? Everybody. Okay, so some of you tried to set this up and you set it up wrong. Okay, so let's look at this triangle. On the big one, what's the largest side? 8. So 8 must be to the largest side on this one. What's my largest side? 4. Does everybody understand that? Are you sure? Are you paying attention? Okay, that must be equal to the next biggest side is 6 on the large one. What's the next biggest side? 3. And that better be equal to the next biggest side, the smallest side is 2. And what's the smallest side? Then we would check this, verifying to see if it's the same. 8 divided by 4 is 2. So 2 is equal to 2, right? 6 divided by 3 is equal to 2. Is it the exact same everywhere? Yes. So by side, side, side. Yes, by side, side, side. Does everybody understand that? Are we all okay with that? Are we going to remember that next time? We've got to remember it till the end of the year. Okay, very good. So if I asked you, okay, what's the scale factor from small to big? What would you say? What's the scale factor? Which means, what did you multiply by to get from the small triangle to the big? 2. Who said 2? You're right. Very good. So did everybody listen? I don't know if some of you are. The scale factor from small to big is 2, because you multiplied each side by 2 to get to the big. So if I said, what's the scale factor from big to small, what would you say? A half. Very good. You multiplied each side by 1/2 to get to here. Does everybody get that? It looks like we need to have a quiz on this tomorrow, because a lot of people don't understand it, and I feel like some people are not really listening or not being engaged. Okay, so tomorrow I'll plan on a quiz on this stuff. Okay, so in class, beginning of class, I'll give you a quiz on it. All good with that, on your grade as a quiz score. So just be prepared for it, okay? All right, moving on. So let's start today's lesson. So today we're going to be learning something before we can get into Unit 3. So I called it the Unit 3 pregame because we have to be able to do this to be able to do Unit 3 properly, correctly, when we're simplifying things. So in Unit 3, we're going to be simplifying a lot of square roots. When we get to some of these problems involving a right triangle trig, and we have to be able to simplify them correctly. Alright, so we're going to be dealing with square roots in this unit. So we know that the square root of some number, it goes without being said that there's a 2 there, so it's written like this, the square root of a number. You all understand that it's a square root, right? But it goes without being said that 2 isn't written. Does everybody understand that? Okay, so keep that in mind. So it is an index of 2. It has an index of 2. It's a square root. Okay. So in the past, we've known how to do this. Most of you are like, so I had a student look at the worksheet and they said, so we'll just use our calculator. And in the past, you've been able to do that. But now, after today, and from here on forward, you're going to have to be able to do this without a calculator. Because I'll explain in a second. So everybody get out your graphing calculators. So what's the square root of 4? The square root of 4, let's type it into our calculator. What do you get? 2. Very good. What's the square root of 64? Do your calculator. The square root of 64 is 8. Right? Are you all practicing typing it into your calculator? All right, well, what's the square root of 8.
2.82.
Okay, so the square root of 8 is 2.82. Okay, so right here is the problem. So that is correct, and you've been able to do that up to here. I've allowed it, it's been okay. But in secondary 2, this would be an unacceptable answer. We have to do this by hand and put it in the most simplified form. And you guys, on an ACT, they would not put this answer. They would expect you to be able to simplify this completely by breaking it down by hand. So that's what we're learning today. So does that make sense? Yes? The square root of 8 is 2.8284272125. You're right, but that answer is no longer acceptable. You have to be able to do it by hand. So that's what we're learning today. So here are the steps to simplifying a square root. Here are the steps to simplifying a square root. First, you're going to break down what's under the root into its prime factors. So I'm going to say that again. The first thing you're going to do is break down what's under the root into its prime factors. Now, prime factors. Prime means only divisible by 1 and itself. Nothing multiplies to be the number except for 1 and itself. That's what a prime number is. So some example of prime numbers would be a 1, a 2, a 3, a 5, a 7. These are all examples of prime numbers because there's nothing that multiplies to be those numbers except for 1 and itself. So I think we're getting pretty good at prime numbers. So we're going to break down what's under the root into the prime factors. Now factors mean what multiply to be that thing, that number. Then once we've done that, second we're going to pull out groups of 2. Because we're dealing with square roots, it's a square root, we're going to be pulling out groups of 2. So if there's 2 of them, it can leave the house. It can come out of the house. And then you'll leave what you can't pull out underneath the root. So anything you pull out, you'll multiply what's outside of the root, you'll multiply it together, and then anything left under the root, you'll multiply back together. And that would be in the most simplified form. And like I said, guys, in secondary 2 and 3 and pre-calculus and calculus and on your ACT, they will all expect you to do your answers like this, and you will run into them. So it's a good thing we're learning them now, and it will really help you. But from here on out, the rest of the year, this is what I expect. No decimals when it comes to breaking down square roots. So here we go. All right, another couple seconds to get down those steps, and then we'll begin. Okay, so we're going to simplify the square root of 8. We just said, okay, yeah, that's great. We could take our calculator and do the square root of 8. We get that huge decimal, which is no longer acceptable. We have to be able to break it down by hand. So we want the most simplified answer, which is not the decimal answer. So what you're going to do is follow your steps. First thing you're going to do is break it down into its prime factors. So what multiplies to be 8? 2 and 4. Very good. So 2 times 4 multiplies to be 8. Now look at your numbers. This is the most important part. This is where students at this level make errors. They don't stop at the right spot. So look at 2. Does 2 break down any further? No, that's a prime number. So that's a prime factor. But does 4 break down further?
Yes.
Yes, 4 becomes 2 times 2. Now this is where the other common error comes in. A lot of people I call double dip. They think that there's a 2, a 4, and a 2 under here. Is there a 4 under here? No. We just rewrote it as 2 times 2. So if you must, cross it out so you don't double dip on accident, if you must. Does that make sense, everybody? 4 is not there anymore. We rewrote it as 2 times 2. So now we broke this down into our prime factors. These are all prime. Does everybody understand? Okay, we're done with the first step. Second step is to pull out groups of 2. So easy way to help you remember this, the reason we're doing groups of 2 is first of all because it's a square root, but just like when you're a kid, your mom won't let you leave the house without a person with you. Like you can't go trick-or-treating without a buddy. So if there's 2, they can leave the house, but if there's 1, it must stay under the house. Does that make sense? Must stay in the house. There's only 1 of them because your mom's not going to let you leave the house by yourself. Okay. So there's 2 2's right there. So we can pull out a 2 for those 2 2's. Now really, guys, what we're really doing is taking the square root of 4. Does everybody see how 2 times 2 is 4? So the square root of 4 is just 2, right, everybody? So we're really just pulling out 1 2, accounting for those 2 2's. So you're not going to pull out a 2 times 2 on the outside. The only reason it can leave the house is because there's 2 of them. So you pull out a 2, counting for those 2 2's. Does that make sense? Okay, so then what was left under the house? That 2. So left underneath the house was a 2. This would be considered the most simplified answer. Okay, so now you can check your answer though. You could say, okay, well, I'm going to check. These are equal, guys. Understand, these are equal. This is the most simplified form though. This is the most simplified form. So you can take your calculator, do the square root of 8, hit enter. You get 2.82, so on. Now I'm going to check and make sure my answer is the same here. So you'll type 2 and then the square root of 2. Close your parentheses. You hit enter. You get the same answer. So that's a way of checking, did I get it right or did I make an error somewhere? Okay. Is everybody good with that one? We're all okay. You understand we only pull out a 2 for those two 2's because what we're really doing is the square root of 4, which is a 2. Yeah.
When you were breaking down that number, like, if it wasn't 4, what are the ones that they were both different?
We're going to get to some examples like that. Okay, so let's do another one. The square root of 24. First things first, break it down into its prime factors. So any factors. Now if you use different factors than the person next to you, that's fine. Because once you get it clear down to its prime factors, it will be the same prime factors. So 24, there's 2 factors, right? 6 and 4, but also 2 and 12. I promise if you use 2 and 12 and you use 6 and 4, and you keep breaking them down, you'll end at the same prime factors. So which one do you want to use, 6 and 4 or 2 and 12?
6 and 4.
All right, so 6 times 4 is 24. Then look at your numbers. Do they break down further? Yes. 6 breaks down into 3 times 2. 4 breaks down into 2 times 2. Now don't double dip. 4 is no longer there. 6 is no longer there. We rewrote it as these factors. So now we can leave the house if there's 2 of them, but only if there's groups of 2. So right here we have 2 2's. They can leave the house. On the outside, we have a 2 counting for those 2 2's. Does everybody understand that? Left under the house, can we pull out a 3? Is there another 3 that we can pull out with it? No, so that must stay. Is there another 2 we can pull out with it? No, so that must stay. So there's 2 things that stayed under the house, the 3 and the 2. So left underneath was 3 times 2, which is 6. So this would be our final answer. Once again, you can check it. Take the square root of 24 on your calculator, hit enter. That is 4.89. Take 2 times the square root of 6, you hit enter, you get 4.89. These truly are the same answer. This is the more simplified form. Everybody's good with that. From now on, if you're given a square root, I expect you to have this answer. That is expected at this level. No more decimals for us. Everybody's good. All right, let's do another one. Square root of 300. Let's break it down into its prime factors here. So 3 times 100. Yep. 100 breaks down into, let's go with, why not, 25 times what? 4. 25 breaks down into 5 times 5. 4 breaks down into 2 times 2. So we've rewritten this as prime factors. Do not double dip. Cross out what you've rewritten if you must. So there's not a 25, there's not a 100. We've rewritten it as these prime factors. All right, so let's pull out groups of 2. So we have a 5 that can leave because there's 2 5s. So a 5 is going to be on the outside, right? And a 2 is going to be on the outside because there's 2 2's. So on the outside, 5 times 2. Left underneath is a 3. So we have 5 times 2, and underneath the house is a 3. So then we multiply what's on the outside. It was multiplied in the beginning. It's going to multiply on the outside. So we're going to have 10 square roots of 3. Once again, this is how you can check your answers. Take the square root of 300, hit enter, then take 10 square roots of 3, hit enter. Oh, I got the same exact answer. This is just more simplified. Everybody's okay with it? You're all good? Do you need more examples? You don't need any more examples. You're ready to try it on your own. Okay, awesome. So then now this is the interesting one. Last thing, really quick. You don't have to even take notes. Just look with me. 25 breaks down into 5 times 5, right? Pulling out groups of 2, there's a 5 on the outside. Was there anything left underneath? No. So the answer is 5. Everybody's good, right? All right. Yes.
So for example, if there was like 3 into the square root, like a number that you can't break down, would that just be your answer?
Like if you had like 5 times 5 and a 3,
Yeah.
then you pull out a 5.
Or if there was
Oh, I see what you're saying. Okay, yes. So sometimes, like, I got what you're saying. If we were looking at the square root of 3 and you said, okay, the only factors are 1 and 3, so nothing can leave the house. So yes, the answer would be just the square root of 3. Great question. Yeah, I'm really glad you asked that. Very good question. Okay, everybody. So do problems 1 through 10. Have me check them as you go. You can check them first, because you know how to check them using your calculator. Not allowed. If you write something like this, and a lot of people are asking, okay, well, if they broke something down and they had a 2 up here, a 2 down here, a 3 up here, and like a 5. Let's say you broke it down, and these are all over the place. Let's say anywhere, if there's 2 3s, they are considered a group. It doesn't matter how far away they are from each other. They don't have to be sitting right next to each other. Does everybody understand that? So if there's a 2 clear up here and clear down here, that's still 2 2s that can come out. Does that make sense, everybody? Okay? Stand. So we're going to talk about rationalizing a denominator of a fraction. So first of all, given a fraction such as 3 divided by the square root of 2, this would not be considered simplified because you cannot have a root of any type in the bottom of a fraction, meaning the denominator means bottom, so you cannot have a radical in the bottom of a fraction. So everybody look at this one. Does everybody see how it has a radical in the bottom? This is considered not simplified, and I can pinky promise with cherries on top, on an ACT, this would not be an answer choice. Because they would expect you to know, okay, I see there's a radical in the bottom, that's not simplified, I've got to rationalize the denominator. So, we must fix it by rationalizing the denominator, like I said. Alright, so everybody, if I had, well, I guess my example's on the next page. Does everybody understand this? When we would need to rationalize. So, let's look at these ones. For example, you just tell me, you don't need to write these down. Would we need to rationalize the denominator on each of these? You tell me. Let's look at this one. Would we need to? Yes. The problem is there's a root in the bottom of our fraction. Would we need to rationalize this one? Yes. There's a radical, a root, a square root in the bottom of our fraction. How about this one?
Yes.
Is there a radical in the bottom? Yes. So this one would need to be rationalized. Does everybody get it? Okay. What about this one? No, there's not a root in the bottom of our fraction. Does everybody understand?
Yes.
What about this one? Would we need to rationalize it?
Yes.
Yes, there's a radical in the bottom of our fraction. So I'm just giving you examples of where you would and would not need to rationalize. You're all good with it, right? All right, so this is how we'll rationalize it. Honestly, the only way for me to teach this to you is just to show you how to do it. Show you by example. So looking at this one, 2 over the square root of 2. Once again, the reason this is not okay is because there's a radical in the denominator of our fraction. So we're going to rationalize the denominator. So what we're going to do is we're going to multiply by that exact thing that's under the root. So we're going to multiply by the square root of 2. Now if you do that to the bottom, you must do that to the top. You can't only do it to a piece of it. If you do it to the bottom, you must do that to the top. Now, I need you all to understand something. Everybody look up here for a second. The reason we are able to do this is because, does everybody see how the square root of 2 over the square root of 2 is really a 1? So we're really just multiplying by a very fancy 1. So anything times 1 is still itself, right? So we're just multiplying by a fancy 1. Does everybody understand why we're able to do this? We chose the fancy 1 to help us out. Does that make sense, everybody? All right, so now on top here, since this is not under a root and this is, you cannot put them both under the same root. The top would multiply, so we multiply fractions straight across. The top would multiply to be just simply 2 square roots of 2. Does everybody understand? If they're not under the same exact root, you cannot multiply them under the root together. So it's just going to be 2 times the square root of 2, which is written like this. Do you understand that, everybody? Now on bottom, these are both under the same square root, so we can multiply them together. So what we're going to have is the square root of 2 times 2, which is 4. Okay, awesome. So then from here, we would continue to simplify. On top, we have 2 square roots of 2, and on bottom, we have the square root of 4, which is 2. If you needed to know that, you could take your calculator, do the square root of 4, and it is 2. Everybody look at the bottom of my fraction. Is there a radical anymore? It's fixed. This would be almost done, the simplified answer. All right, then you would check, is there anything on the outside that could simplify further? And you would check to see if your radical is broken down all the way. Can we break down 2 any further? No, that's the most simplified root. But is 2 over 2, 2 divided by 2? Well, yeah, that divides to be 1. So 2 divided by 2 divided by 2 becomes 1, 1. So we really just have 1 times the square root of 2, which is just the square root of 2, right? 1 times the square root of 2, and then divided by 1 is just the square root of 2. So this would be the most simplified answer. Now, I need you to understand something. These are equal. They are equal, but this is considered the most simplified form because we cannot have a root in the bottom of our fraction. It's called rationalizing the denominator. From now on, if you were to get to an answer, and in this trigonometry unit that we're about to get into, if you were to get to a final answer where you had a radical in the bottom, I would expect you to simplify it. Does everybody understand why we're learning this today? Okay. All right, let's do another one. So we have 3 over the square root of 5. First of all, the problem is that we have a radical in the bottom of our fraction. So we must rationalize the denominator, make it more simplified. So we're going to multiply by the square root of 5. If you do that to the bottom, you must do that to the top. And once again, that's just a really fancy one. So we're really not changing anything, we're manipulating it to our advantage. But we're doing it in a correct manner. So then we multiply straight across. We multiply the top straight across and the bottom straight across. So on top, we're going to have 3 square roots of 5 because they're not under the same root, so we'll leave it as it is. And on bottom, we have the square root of 5 times 5, which is 25. So on top, we have 3 square roots of 5. And on bottom, we have the square root of 25, which is equal to 5. Very good. Now, everybody, listen up very carefully. You cannot divide something that is under a radical with something that's not. So a lot of people at this level say 5 and 5, those must divide out. That is not true. You cannot do that. This is under a radical, this is not. Thus, you cannot divide them. Do you all understand that? Very important. So does 3 and 5 simplify further? No. So this would be our final answer. Now, once again, this is actually the exact same thing as that. This is what you would see on an ACT. This is what you're going to see the rest of the year. This would be the correct answer. This would not be considered simplified enough. Okay. Just a couple last ones, and then I'm going to let you just work. So, last 2 or so examples. Here we go. -4 over the square root of 3. You tell me, what am I going to, well, what's the problem? We have a radical on the bottom. What am I going to multiply by? Well, the square root of 3. If you do that to the bottom, you must do that to the top. Now on top, you multiply, okay, so on top and bottom, we multiply straight across. So we're going to have -4 square roots of 3, right? Everybody?
Yes.
And then on bottom, we'll have the square root of 9, which is, so -4 square roots of 3 over 3. Can you divide the 3's? No, this would be the most simplified answer. Ari, do you have questions? Okay. Last one, because this one's a little bit trickier. Actually, I was going to do 2 more because it can get trickier. So we have the square root of 2 over the square root of 3. The problem is not the top. The top's totally fine. We can have roots in the top. The problem is that there's a radical in the bottom of our fraction. So we're going to multiply the bottom by the square root of 3, the top by the square root of 3. Now this time, are they both under the same radical on top? Yes, so we will multiply those together. That's the square root of 3 times 2, which is the square root of 6. Does everybody understand? 3 times 2 is 6. Okay, divided by the square root of 9. All right, well, what is the square root of 9? 3. So on top we have the square root of 6, and on bottom we have 3. So then you would just make sure that your top doesn't simplify further. You go off to the side, say the square root of 6 is 3 times 2, right? And you can't pull out either of those. So So the square root of 6 was truly the most simplified it gets. Does everybody get it? Okay. Last one. Promise. And it's the most rigorous one. So we have 2 square roots of 3 over 4 square roots of 2. There's a couple different ways we can go about rationalizing the denominator here. I debate on which one to show you. So I guess what I'm going to do is the one way. I don't know. It's debatable. All right, so first of all, the problem is the radical in the bottom. The 4 is not the issue here. Does everybody understand that the 4 is not the issue? The 4 is fine. Leave it alone. We do need to fix the square root of 2. So we multiply the top and the bottom by the square root of 2. Does everybody get at that? So on top, we multiply straight across. Now on top, there's a 2, a square root of 3, and a square root of 6. Well, the 2 is not under the radical, so it stays on the outside. But we do have a square root of 3 times 6, which is the square root of 18. Everybody okay with that? 3 times 6 is 18. The 2 is on the outside. Some of you are looking blank, so ask the question. I have no idea. I can't answer your questions if you don't ask, because I have no idea what didn't make sense. Yes? Oh, I did the square root of 6 randomly. Okay, see? That's why we ask questions. Thank you for asking. Ding, ding, ding. Ding, ding, ding. No wonder you look so blank. Okay, so the square root of 2 over the square root of 2. There we go. So on top, we have 2 square roots of, I was thinking ahead, right here is where I saw the 6, and then put the 6 down. The square root of 6. Okay, there we go. Are we all okay now? Okay, good. And then on bottom, we have 4 times the square root of 4. Everybody's okay, right? So on top, we have 2 square roots of 6, and on bottom, we have 4 times the square root of 4. Well, what is the square root of 4? 2. So we have 4 times 2. Does everybody understand that? We're all okay? Okay, so really what we have is 2 square roots of 6 over 8. Now let's look. Does anything on the outside simplify further?
1 square root of 6 over 4.
Good. So let's say why you got that you're right, Caden, but what did you do?
You take the 2 and 8 on the outside and divide it by 2.
Good. Very good. So the 2 and the 8 are on the outside. They both divide by 2. So that became a 1 and that became a 4. Very good, Caden. So on top we have 1 times the square root of 6, which is just the square root of 6. And on bottom we have a 4. Very good. This would be our most simplified answer. Now once again, you would really need to make sure that all your radicals are completely simplified. Because you are going to have a few on your worksheet where you'll have to simplify them further. Okay, do you feel comfortable to try some of these on your own? Okay, so if you're not doing okay, we'll come back and do this one. I was going to do one more, but I think you're ready to try. So do 11 through 16, and once again, be sure to simplify all of your radicals completely. All right. Looking at this one, I would go about it a totally different way than most of you, but that's okay. I'll go the way that you guys are going. So most of you just started here. You did the square root of 8 over the square root of 8, yeah? So on top, we have 8 square roots of 40 over 4 times the square root of 64. Is everybody following me? You're sure? Okay, so on top, we have 8 square roots of 40, and on bottom we have 4 times 8, right? The square root of 64 is 8. Are you all listening?
Yeah.
So really what we have is 8 square roots of 40 over 32. All right, so does 8 and 32 simplify?
Yes.
What does it do?
1/4.
1/4. Okay, so how many of you have the square root of 40 over 4 as an answer? Okay, awesome. You're not quite there quite yet. Okay, so we got to keep going. Now here's why. You have to ask yourself every time when you get to the end, does my radical break down further? Yes, the square root of 40, I'm going to go off to the side and just break it down. 4 times 10, 4 breaks down into 2 times 2. So we pull off roots of 2. So we have 2 square roots of 10. Is everybody following me? So on top, we have 2 square roots of 10, and on bottom we have a 4. Now again, does it simplify the outside? That becomes a 1, that becomes a 2. So our final answer would be the square root of 10 over 2. So I need you to go back and look at all of your answers and make sure they're completely simplified. All the way down, all your radicals are completely as simplified as they can go. Okay. No questions on that one.